This video is a walkthrough of Chapter 4 of Building Java Programs. This is based on the slides of Amelia Gahn. Thank you very much, Amelia. So this week is really about if statements, if-else statements. And I know a lot of you have been using if-else statements in your code so far. And what I can tell you is that a little bit of knowledge is a dangerous thing. So if statements are one of the most fundamental statements in computer science. All assembly languages have comparison operators in them and jumps. But the problem is that people have been using if statements to solve problems that they shouldn't ever have gotten themselves into. So for example, if you write a for loop and you don't quite get the expression right, you can throw an if statement in to solve the problem. And that is not a good use of if statements. So as we go through this chapter, keep in mind what is a good use of an if statement and what is a bad use of an if statement. So as most of you already know, the if statement is very simple syntax. If, and then you put the conditional in here. This conditional can be an individual condition. It can be multiple things strung together using logical ands and ors. And then you can have some braces with statements, or just like in the for loop, you don't actually need the braces if you only have a single statement. And there's of course the else. So if a bunch of statements, else. You can have another, well, I guess we'll be getting to else if again later. But so you have if this one isn't executed, then you can jump to this. Okay, so this is a technical definition. You won't see this kind of flow chart in anybody's office. This is Microsoft, but for books, this is a good idea just so you're completely clear as to what the flow is. These should all be familiar to you from Python, except that in Python you could also do less than greater than for not equals to, and you cannot do that in Java or C. So I would get used to the exclamation point equals as not equals. Precedence. So the main thing to remember is that it's easy because equals has a pretty low priority. It has lower than any of the other mathematical or arithmetic operators, but it's important to note that that says arithmetic and not all operators. There are cases in which equals has a higher precedence, and we'll be taking a look at that in a little bit. So when you write code, then generally it just makes sense with the equals sign. So here's a simple example of sequential if statements. So in this case, each of these tests is going to be run regardless of whether one of the other statements was run. So it'll independently execute each of these three statements. Here is the nested if-else. Technically, the nested if-else, you would actually put everything here within this bracket and this bracket. This is like actually a step further. But basically, if you want to execute one at a time, but if you pass any of these, then you want to skip all the rest of them, then this is what you want to do, if-elses. And then most of the time, you really want to do it like this, where there's a last statement that's a catch-all. So if none of the other cases worked, then this is the case here. This is a good chart that will help you decide which form of if to use. The first case is if each test is independent of the other test, and you want to be able to execute potentially both of these code blocks, or however many tests you have, then go ahead and use this simple if form that's sequential. Otherwise, you're going to be doing some nested ifs. The difference between these last two is whether or not you have a test for each particular one, or whether you have a catch-all at the end. At this point, I want to go off script and teach you something that is not in this chapter of the book, but actually is in Appendix C. The reason I want to teach it is because it is related to ifs. It simplifies a lot of code that looks really complicated with ifs. So there are two things I want to teach you. The first is what's called the ternary operator. It's called the ternary operator because it's the only function that takes three different operands. It takes a condition, and then it takes an expression for whether that condition is true, and it takes a condition for the expression is false. So you typically have code that's like this: if some test, then do some code with one expression, or you end up doing the exact same code with another expression. It's oftentimes done as an assignment. So maybe you have some value equals this value, or some value equals that value, And so instead of that, you can use the ternary operator. So in this case, instead of having separate printlns, I've created one println, so you don't need any of this code here, and you can just do Control/ in Eclipse to comment that all out. And so now what it's going to do is going to do system.out.println. If A is greater than B, it'll println the greater, otherwise it'll println less. So let me go ahead and run this and then go back at the top. Yeah, so it's printing greater, okay? And here's another thing. So here's that assignment. So greater is equal to, if A is greater than B, then A, otherwise B. Okay, so it's just the assignment. And then it prints in the greater, which is the greater value here, 3. Okay, the second thing I want to teach you is switch. And in fact, I can think of some code that you're going to be doing in this coming homework assignment that could benefit from switch. So switch is useful when you've got a whole bunch of things beyond 2 or 3. You never see a professional programmer do if something else, if something else, if something else, if something else. We use switch statements, and switch statements can be much more efficient because they can be done as a dispatch table. But anyways, if you have something that can be, it's not a complex evaluation, but rather it evaluates to a simple number or a character, you can use switch statement. So in this case, I'm switching on the value of B, and I've got 2 specific cases here, case 1 and case 2, and otherwise there's a default case. So this is like leaving off the if at the end of the else ifs. So depending on what B evaluates to, it'll go to whatever case statement is, or it'll go to the default. You don't have to have the default. And then it executes the code starting from there. Now, a result of that is that you typically put break statements after the code. Break will then exit this switch statement. Otherwise, it does what we call falling through. So if it's 1, then it's going to print this here and then exit. So let's set B to 1 and just go ahead and run this one. Control F11. Actually, let's semicolon. Okay, so let's run this. Okay, so it says uh-oh, but that's all it does, okay? And then let's try B as 2. And let's run that again. And now it should say yeehaw and then fell through, okay? If we want to prevent that falling through, we just add the break statement there. Now let's run it again. So now it just says yeehaw and then does not fall through. So you aren't required to use either of these, but if you want to use either of them, you can. It will really simplify your code as you start doing more and more complex code. All right, let's go back to the book chapter now. Okay, so now we're moving on to, I believe, to strings. For strings in particular, equality should not be tested using equals equals. The object class, which all Java objects are built on, treats equal equals as only being true if the 2 objects are the exact same object. And we won't go into too much details about that. If you've learned C, then I can say that only if the 2 objects point to the same location in memory, okay? Whereas there's another function called equal that, let's go on to the next page. So equals equals here doesn't do the right thing here, because even though if you execute this scanner here and you get response being Y, it's not going to work because they're not the exact same object, even though they both contain the same letters. Instead, what you want to use is response.equals. So response is a string, there's an equals method, and that will compare the contents of this string to whatever response's contents has, and this will work. And there's a third weird case where if you have 2 literals, string literals, by some weird reason the Java language specification says that 2 string literals are always going to be equal. And that's confusing because you can start out doing code like this and it'll work, and then you replace them with non-literals where you've maybe inputted them from the user and they don't work. So just in general, you want to use the .equals function and not equals equals. Let's actually take a look in Eclipse at how this works. So I've got some code here to println enter your response, get the input, and then do that exact test. So let's go ahead and run this. Enter response. I'm going to type in y. Okay, so it prints out y and then didn't work. So what did it do here? If the response is equal to y, it should have printed out work, but it didn't. So that's what I was saying, is that response, even though the contents of response is the same as y, they are not exactly the same object. They're two separate objects that have both y in them. So if but if I do the response dot equals y, then I get this statement, equals equals didn't work. Okay, the text may be a little bit confusing to you, but if you look at the code here, that's what I expected. Okay, so let's go back to the slides. All right, so testing multiple conditions. I was saying earlier that the if statement can have multiple tests in it. If you have multiple tests, you want to use the logical and or, and that is using an ampersand for and, or two pipes for vertical pipes for or. And one thing that's not mentioned here, but is important to note, I actually just saw this bug in my own code earlier. So up until this point, we've talked about how the equality operators, equals, or in this case not equals, are lower precedence than all the arithmetic operators, plus, minus, divide, times. But now that we introduce logical operators, we're going to see that logical operators are actually even lower. So here's three of the same sets of comparisons using the ternary operator. And in the first case, I have forced the OR operator to evaluate first. In the second case, I have forced the equality operator to evaluate first, and then I have just left it up to its own. So the question is, which of these ways do we expect it to happen? So far, we've been saying we can just do things kind of logically and it'll work. So you might think, okay, true or true, that's going to be true. True doesn't equal true, that's going to be false. So that would give us that the inequality operator is going to be last. But let's see what happens. So we're going to hit run. So you see that when I force this, then it shows that the inequality is going to be last. But that is not the case. So when I force inequality to be first, it shows that the OR is last, and when I don't have any forcing whatsoever, it shows that the logical OR is last. So there are actually very few cases where this happens, but it can happen. So just remember that generally you don't have to worry about putting parentheses when you have an inequality comparison, but if you're involving logical operators with a complicated if statement, you are going to need to put parentheses around things. Otherwise, this may evaluate differently than you thought. Okay, so let's go back. Next, we're going to cumulative algorithms, and you've actually seen a fair number of cumulative algorithms. You've probably already seen the cumulative string algorithm, where you're going through a string and you're adding one character at a time. So this just gives some more examples. You can find the sum of a list of numbers by going in a for loop for all the items and adding up the sum. Of course, it's always important to set the sum. Okay. Here's another example where you're going to find the maximum. So now you're going through that item, and then you've got a max value. You want to initialize max, and when you find problems like this, you might actually find it helpful to use the smallest integer or the largest integer. And if you just type, so let's say int max equals integer dot, you can actually see there's a max value and a min value. In this case, if you're finding the max, you'll probably want to use the min value. Okay, so that's how you can find out what the real minimum value is. So you're going to initialize that max to be the min value, and then you can go through, and if the value is greater than max, you can reset. Some more ideas, you can, finding the minimum, that's the same thing, except instead of setting, you're going to use the smallest possible int, you're going to use the min to, set min to the largest possible int. Cumulative sums, so you can count the occurrences of a letter, and in our case, we've already seen an example where we counted, where we built a string by going through all the characters in a string. All right, next topic is roundoff errors. So round-off errors can occur. I knew that Excel used a very special format for storing numbers. It was IEEE 754, but in researching it, found out Java actually uses the exact same format. So both of these, Java and Excel, can run into these rounding errors, and I actually verified through some samples that sure enough, Excel can have the same type of errors, but they're very rare, and indeed most people dealing with currency and things in Excel, you don't need 15 digits of precision, or if you do, you've got bigger problems. So that's why it's okay in Excel. And Java also provides a class called big numbers, which can be used to avoid those problems, but you really probably don't need that. So round-off errors can occur, especially in cumulative algorithms, because you keep on adding, or multiplying, and you start to get more and more important digits. And so then trying to compare two things could be difficult. So the suggestion is to use the math.abs method to subtract a little bit. So instead of saying A equals B, you could say the absolute value of A minus B has to be less than some particular threshold. Okay, and I think you may be needing that in problem sets. Okay, next topic is text processing. So you've already done a fair amount of text processing. This slide talks about the char primitive, and I want to point out that those of you who are used to C or want to learn C, the char primitive in C is different. The char primitive in C is guaranteed to be 1 byte. The size of char is 1 byte, whereas in Java it is not. It is actually 2 bytes, and we'll see in just a minute. So you can assign a char, you can assign an escaped char. So the main difference between chars and strings is really that the strings have multiple chars. Strings are arrays of multiple chars, okay? And you can store a single character can be stored as a string object, but a single char can be simpler. And so in most problem sets, we're just going to be using the string object, but occasionally you might find it useful to pass around a char object. But then when you do that, then you might have to compare it to a string, and then you're back to where you started. So this is talking about what I was mentioning, that chars are stored as 16-bit integers in Java. And I'll give you an industry minute. We oftentimes think with kind of ridicule that there used to be a day when everyone thought the Earth was flat, but it actually happens all the time. And I remember in my career working in Excel when the day that the world changed its shape, because we had always been taught that strings are arrays of characters. Those characters were always 1 byte, and that's it. And so we had code everywhere, and I do mean everywhere, that looped through strings just by indexing into the character arrays directly. Then along came the Japanese market, and what's what we call the multi-byte character set. So Japanese characters can have not 1, they always have at least 2, sometimes 3, maybe even 4 bytes of characters, 4 bytes per character. And that became a huge problem, and we literally had to rewrite, thankfully with a lot of tools, every single line of code that went through characters. So instead of char plus plus, we'd have to call a little function that would check to see how big the character was. So don't be surprised if something like that happens again in the future, because even Java doesn't really handle this right. Char at does handle it right. Char at will tell you, it'll take into account whether a Unicode, so this standard Unicode encoding that they use does handle multi-character extended characters. So a character may actually be more than 1 integer, it may be 2 integers. And char at will figure that out for you. But if you were to actually take the string and look at the array of characters and manually index into them, or try to guess the size of that string, you could be wrong. You could be wrong. And Java kind of washes over this in a little bit in a slightly dangerous way. So don't be surprised if someday you wake up and realize the world isn't flat either. Okay, so getting back to the topic at hand, you can treat characters and integers kind of interchangeably. So you can do math on characters. There's not a whole lot of good reasons why you want to do this at your point, but this is done quite a bit in industry. Okay, so here's a bunch of examples of characters and integers. I think it's pretty straightforward. You can read the examples yourself. Cumulative text. Okay, so we talked about some cumulative text algorithms. You can use the plus operator, which has been overloaded for strings to be concatenation. You can use it to reverse a string. We've done it to pad a string. Okay, formatting string output. This is straight out of C. This is straight out of C. So printf is what C had, and Java couldn't figure out a way to get around along without it. So thankfully, they decided to include it. Printf is useful for formatting. That's what the F stands for. It's for formatting your printing. So I'm just going to go ahead to the next slide and show you some examples. So you do a system out printf, and then you have a format string, and then you have parameters. I actually want to go one more slide, but let me just show you that format specifiers have a %sign, and if you need to put a %sign in, you actually have to have 2 %signs. Let's take a look at some of these format strings. Okay, here we go. So you have the first item is a quoted string, and you can put whatever text you want in here. So you notice that when you did just a system out print, you had to put string plus variable plus string plus whatever. You can do all of that here in one string, and instead of adding variables, instead what you could do is use a %something to specify that you're going to put a variable in that spot. So in this case they're using %d, which unfortunately really probably should have been something else, but that just means it's an integer. Okay, so d is integer, so it takes an integer here, and then it prints those integers there. Here they're showing you need 2 %signs in order to get 1 % in the output. Here they're showing you the F for floating. So the 0.2 specifies you're going to have 2 digits after the decimal point. Okay, the $sign is translated directly. The % is telling us that's what we're going to use to substitute in price. And then there's a \n in here. That's the other important point, is that printf doesn't include \n. Okay, so this is a topic which I'm actually surprised that they introduce you to, because it's really an advanced topic. The topic is checking before and after your function to make sure that everything has been done correctly. And the language that I learned in, and a language that actually Java borrowed many features from, called Clue, this was called asserts. So we would assert at the beginning of every function what we thought was true, and assert the same thing, or maybe something slightly different, at the end. The problem is that at this point in your education, you haven't really used a lot of data, and these asserts, these preconditions and postconditions, are really about data. So let's take a really complex example, Microsoft Excel. Okay, so you're operating on this huge spreadsheet of data, but you want to make sure that after you've done your operation, whether it be inserting a cell or doing some calculation, that you haven't completely screwed things up. And so literally before and after every operation in Excel, we're going in, at least in the debug version, and checking to make sure that everything looks okay, that it looks like a valid cell, that the numbers are within our expected ranges, and all the time in our debug versions of Excel, it is continually checking every single cell in the entire spreadsheet to make sure that everything looks okay, that all the formulas look okay, that all the values look okay. And that's, again, one of the reasons why Microsoft Excel is so rock solid, is because really the vast majority of cycles being burned in Excel by developers is testing, always testing. Okay, so it's a great topic. It's a very important topic, but I honestly think it's too early in your education to be learning about these. Okay, one thing that I think people are going to expect you to be able to do in 143 is to throw exceptions. So if you do an assert, or you do a precondition test, and you find that that is not correct, then you should throw an exception. The simple case that they deal with in these programs is you ask for, let's say, a numerator and a denominator, and you get a denominator that's 0. Well, you should probably throw an exception there. Or you ask for a file, and that file doesn't exist. You want to throw an exception. So it's pretty simple to throw an exception, and you just need to know how to throw an exception pretty much for 143. I don't think you can handle it, but I don't think they deal with that too much. Okay, so that's a topic that's important, but really not at this stage of your education. We're going to spend the next couple slides looking at return values and handling errors. So here's a simple routine to get the maximum. If A is greater than or equal to B, return A, otherwise return B. Those of you who were paying attention during the ternary operator might recognize that this would be an excellent opportunity to use the ternary operator. Here she's saying that only one return will be executed, either this one or this one. A ternary operator guarantees that you're only going to return one because there will only be one return statement. Okay, so index of method, we've already seen how to do index of, but let's talk about what the return values are. The important part here is if the letter we're not searching for is not in the string, we need to return -1. So let's take a look at the next slide where there's some code. So here it's iterating over the length and it's searching to see if the letter is there. If it does find it, then it can return the index. Otherwise, it's going to return a -1. So that is, instead of throwing an exception in this case, we're returning a special error value. So that's a simple example of using a return value to specify an error instead of throwing an exception. Concluding comments. Okay, so to repeat myself from the beginning, if else, a little bit of knowledge is a dangerous thing. Don't be using ifs unless it's really something that can only be handled by ifs. Even if you do the ifs and if else's correctly, it might still be better formed as a ternary operation or as a case statement. If you ever get an if else that's going on for 4, 5, 6 different if else's, think that there is a better way to do this. Okay, again, I've never seen a professional programmer have to go to those lengths. Relational operators. So equals equals works on primitives. You don't want to be using equals equals on strings or any objects. So use dot equals instead. Round off errors. So here we use the math.abs of one minus the other is less than some certain amount, some tolerance. Chars are stored as integers. That's 16-bit on most platforms. If the strange thing is that it can actually take more than one integer in order to store a single char. Java hides that from you as long as you use the char at primitive, the char at method. Okay, if you actually try to index it yourself, you may get it wrong. Okay, so that gives you a good overview of how ifs and if else's work, and I hope you also learn and decide to use the ternary and switch statements, but it is not part of the course. You're not going to be graded on it. It's not going to be any of the quizzes, but I think any of you who want to become professionals, you will learn to love those two features much more than ifs. Okay, thank you very much, and good luck on your problem sets.